Hola, Kinder. Mixing my Spanish with my Deutsch. We're going to do inverse Triggy today, so open your notes to section D. And we've done some stuff with the inverse trig functions, arctan, arcsine, arccosine, but not a whole lot. We did do the derivatives. We said these two are worth memorizing, and the other ones we wrote down, but we never really used them. And this is really an A-B topic, but we're covering it after the exam because I knew they wouldn't ask you to do this part of it. So let's revisit. We already know, we did this one a couple days ago, so I'm not going to derive that again because we derived that on Tuesday. So let's go put that one on our chart. The derivative with respect to x of tan inverse or arctan x, depending on what text you use, is 1 over 1 plus x squared. However, if this had been a function of x, which we usually call u, it ends up being u prime over 1 plus u squared. So you might want to write that down as well. When it's just x, u prime is 1, so that's why there's the 1 on the top of it. But it's u prime over 1 plus x squared. And we already derived that on Tuesday. So we're going to do these two that we didn't do on Tuesday in a similar fashion. So what is the derivative of arcsine x? I forgot. I'm going to go Google it. Go ahead, but I'm going to show you how to derive it. What we're going to do is let y equal arcsine. We are going to get rid of arcsine because we don't like it. So we're going to sine both sides. We'll get sine y equals sine of arcsine, which is just x. What that means is I've got some angle y, so I'm going to put a little helping triangle over here, whose sine, remember sine is opposite over hypotenuse in our SOHCAHTOA model from way back in geometry, whose sine is x over 1. What that means is opposite over hypotenuse is x over 1. So we'll go back to the triangle later. My goal is to figure out what's y prime because I want the derivative of arcsine. So I don't want y, I want y prime. So what I'm going to do is take the derivative of both sides. The derivative with respect to x of x is 1. And I forgot something, kind of on purpose, but not really. I'll say it's on purpose, but I actually did forget it. I forgot my chain rule. So remember, it's the derivative with respect to x of sine y is oh, I didn't forget it. I haven't taken the derivative yet. What is wrong with me today? I didn't have enough coffee this morning. So the derivative of sine y, and remember our sine, cosine, blah, 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 is cosine y times the derivative of the guts, or y prime. Again, when there's no variable match, the derivative with respect to x of sine x is cosine x. But when it's the derivative with respect to x of sine y, it's cosine y prime. And that equals 1. Also, keep in mind, had this been a function of x, like a u, that would be a u, and the derivative wouldn't have been 1, it would have been u prime. So that's why when we do the derivative with respect to x of arctan u, we'd get a u prime. But we're going to keep it in its simplest form. So my y prime, the derivative of arctan, because here's my y, and I'm finding y prime, is going to be 1 over cosine y. So back to the triangle. What is cosine y? Cosine is adjacent over hypotenuse, so it's something over 1. What is the adjacent side? Well, the Pythagorean theorem says that question mark squared plus x squared is equal to 1. That would mean question mark squared is 1 minus x squared, which leads us to question mark being 1 minus x squared. And that's the ugly one, and maybe you had that memorized, but if not, there it is for you, derived and ready to go. So the derivative with respect to x of arcsine x is 1 over, remember it's the uglier one, it's got the root, and we've done this before. This is just a review so it can help us integrate. Remember, derivatives and integrals are tied as tightly as squares and square roots. And again, had this been a u, I would have had a u prime over the square root of 1 minus u squared. So the last one I'm going to do in a very similar way, will be arcsecant, and I'm going to do it exactly the same process as this in the same way we did arctan. Let's have at it. Here we go. This is fun stuff. We've got y equals arcsecant x. Hate arcsecant. Let's undo it. Let's secant both sides. The secant of arcsecant is just x. Leads us to a triangle whose secant is x. Well, if cosine is adjacent over hypotenuse with our SOHCAHTOA, then secant is going to be hypotenuse over adjacent. So what I know is that hypotenuse over adjacent would lead me to x over and a 1 on the leg. And let's just go put the missing leg in because you can anticipate we're going to need to know it. So 1 squared plus question mark squared equals x squared. So x squared minus 1 has to equal question mark squared. So this is going to be the square root of x squared minus 1. And you can Pythagorean theorem it out if you want, but I kind of just talked it out for you. So what's up next? I do the derivative with respect to x of both sides. The derivative with respect to x of secant is secant tangent times y prime. The derivative with respect to x of x is 1. And again, had that been a u, we'd write a u prime there. So my y prime will be 1 over the product of secant of your angle times the tangent of your angle. Well, the secant of your angle is just x. We already know that. The tangent is opposite, TOA, over adjacent. So it'd be the square root of x squared minus 1. Usually what you see on this one is absolute value bars here because we say that that longest leg can't be negative. That's a very loose reason why, but anyway, we did that one. Let's say arc secant x would be 1, and again, if it was u, it would be u prime. Over on the bottom, we had an x and a root x squared minus 1, and technically that should have absolute value bars on it. So what about the other ones, which we're not going to work with, but I'm going to put them on here so that at least I can say I told you them, even though we're not going to use them. These two are big hitters. How about what's the derivative of cotangent? It's exactly the same, whoopsie, it's exactly the same as tangents. The only difference is there ends up being a negative. And that's the same for all of the cofunctions. All that you introduce is a negative. And you could go derive them just like we did these, and you could see that negative form, but we're not going to waste our time doing that. So what am I on here? Cosecant x would be negative 1 over the square root of 1 minus x squared. And the last one would be the derivative with respect to x of arc cosecant. I already did that. I've got cotangent, cosecant, oh, cosine. This one's cotangent. This one should be cosine. Sorry, I'm screwing you up here. And this are all the cofunctions. This should be cosecant. X would be negative 1 over absolute value. And again, we're not going to use the right-hand column, but a good thing to put in your memory bank that all the cofunctions, cotangent, cosine, and cosecant, I should write those a little neater, co-function for secant, and it should say arc. Man, I'm sorry, I don't want to redo this video though, so I'm going to put my arcs on here. I'm getting sloppy, Poppy. The left-hand column is what we're going to work with. So now this is what's new. How do we integrate these? Well, this one, you really shouldn't really need to think about it because it's the derivative of what is 1 over 1 plus x squared. And that's in your face, this one. So the antiderivative of 1 over 1 plus x squared is just arctan x. Same here. Because again, if I took the if I took the derivative of my antiderivative, I'd get the integrand back. Over here, same thing. This is just in your face, arc sine x plus c. So these are in your face ones that we recognize. But what if we just kind of keep the same format, but we change it up a little bit. What's going to happen? Well, we've got some models we can use, and I want you to, sorry, my proctor typed these in. We've got a little sign error there. You'll notice that this looks very much like our ugly one, our arc sign. It's got the root, it's got the subtraction, but what I'm saying is, what if this wasn't a 1 right here? What if that was something else like a 9 or a 16 or even a 5, which is root 5 squared? There's a general format for this. You'd recognize, hey, that looks like arc sign. And it's arc sine u, whatever u is, over a plus c. And we derive that in Calc 2. For today, we're just going to use it, and you can look. Same here. This looks very arctan-y. It's got our nice something squared plus something, no root. And this is going to always be 1 over a arctan u over a plus Carl. The way we remember this in Calc 2 is we say it's 1 over analysis, arctangent, year in analysis. Sounds stupid, but just like Liate, it's going to stick in your head. And ooh, duh. My poor sub probably thinks I'm talking in a 4 language here. They know what I'm talking about, I promise. So again, these get proved in Calc 2. The proof of them would take me the rest of the hour. And today I want to give you just a little heads up on what's coming next when you go to college and do a little practicing. Well, example 1, that's in your face, but suppose you didn't recognize it. What is A? A is whatever's is being squared right here, which is 1. What is u? U is whatever's being squared right here, which is x. What's du? It's just dx. So that's in the form up above. It is in the form 1 over, there's an extra dx here, 1 over a squared minus u squared under the root du. So this is just arc sine. This is just arc sine u over a. It's just arc sine x, and we did it on the previous page. So that one, again, it's in your face. You shouldn't need to go through this whole process when it is exactly in the right form. Now, example 2, not exactly in the right form. So what we're going to do is we're going to pull that 5 out front because we like to always pull our constants out front. We're going to go 1 over the square root of 4 minus x squared dx. And we're going to say, who does this look like? It looks arcsine-y. I don't know if that's a word, but it does look like it's in the arcsine format. So if I can get it in the right form, a squared minus u squared du, I can use that model up above. And this one you could probably do in your head, but I'm going to write the process down for the more difficult ones. A is equal to 2. U is equal to x. Always take du, because if it's not exactly dx, you're also going to need to provide the appropriate fraction correction. So I've got 5 times the integral of 1 over a squared minus u squared. And it says up above that that's arc sine u over a. And you can just use the models up above, and that one would be done. Let's look at example 3. Again, I'm going to pull the negative 2 out front. I end up having this in my integrand. This shouldn't require any more work because this is an antiderivative you should know right now. That's arctan. You might say, well, you said it's 1 over a arctan u over a. Well, it is, but a is 1, so 1 over 1 is 1. Arctan u over a would be x over 1, which is just x. So that's in its most bare state. That's just arctan x plus c. Now, just for fun, let's, because you know it's always so much fun, let's make this a definite integral. And let's go from 0 to 1. In which case, I would throw my limits on here, and I would use my fundamental theorem of calculus that says that that's arctan of x, which would be 1, minus arctan of 0. And let's revisit what our arctan or our tan inverse functions do. It would say the tangent of what angle is 1. Sine over cosine is tangent, and I want to know when is it 1. I want to know at what angle, because the inverse functions spit out angles. The original function spit out their tangents and cotangents. So the tangent of some angle is 1. What's the angle? Well, where is sine equal to cosine? And that would be at pi 4. So I'd say pi over 4. And then I'd have minus arctan 0. Well, sine over cosine is 0 where? It's 0 when the numerator is 0. Where is sine 0? Right here. Not that you're necessarily going to have to do that, but I just kind of wanted to throw a couple at you that have some twists to them. So let's move on to the next page. Hopefully, turn the page. All right, a little more complicated, so let's beef it up a little bit here. Example 4. You might not think this is a squared, but it is. This looks very much on the bottom. Again, I don't know why she's putting extra dx's in there. Let's go take a peek. This looks very arcsine-y. Don't know if that's a word, but we're going to make it one. I hereby declare arcsine is a word. It does. And I can do this if I can identify my A. My A is whatever's being squared to get this. Well, that's not like a nice 9, so I can't just say it's 3. But how about root 5? Oh, super. My U is whatever is being squared to get this. It's not just x this time. It would have to be root 2x. Now here's the deal. When I rewrite this, I am trying to get it of this form. I'm trying to get it of the form 1 over the square root of a squared minus u squared du. So in this case, du is not just dx, because when I take the derivative of this, I get root 2 dx. So when I go replace this with du, I actually need to replace it with the fraction correction in place. And this is what most kids forget to do. So make sure you run that through. If there's any mistake, that's what you're going to forget. These are sometimes on the BC exam, and one of the multiple choice answers is always the answer with the fraction correction being forgotten. So let's go up here, and remember, when I have it written like this, my answer, once I get it all laid out, is arcsine u over a. So my answer is arcsine, what is u? U is root 2 times x over a plus c, but that's the person who forgot. You've got a fraction correction going on there, because when I write it with my du, right, and I replace that dx, I have to replace it with 1 over root 2 in this scenario. So this is really it. And the denominator might get rationalized, may or may not. You know how to do that from Algebra 2. So I'm not going to rationalize the denominator. Beware of one like this, because you might say, hey, that looks arcsine, but it's really not because of that x on the top. This would actually be a u sub problem, and I'm not going to carry it on out. But u would be the inside function. Du would be negative 4x dx, and with a negative 1/4 fraction correction, this is just straightforward u sub that we could have done months ago. Example 6, I'm actually going to change, because as it stands, example 6 is u sub. U would be the bottom. Here, let's go do this. Let's go do this one as it stands. Let's say u is 9 plus e to the x. This is a squared, but this isn't u squared. So this is not, kind of looks arctan-y, another new word I'm going to make up, but it's not. My du would be e to the x dx. So this is just a nice u on the bottom. The whole rest of it is du. That's really what I've got going. And that's old-fashioned. We've done those before. Old-fashioned, not old-fashioned. Old news. Absolute value of u plus c. But instead of doing example 7, because these are actually from my Calc 2 notes, and that one gets a little more involved than what we need to do right now, I'm going to go tweak example 6 to make it a little bit different. I'm going to put a 1 here. Still going to put a dx here, but I'm going to put a 9 plus e to the 2x here. Now it's arctan-y. And remember, the arctan format is when it's of the form 1 over a squared plus u squared du. When I get it in that format, I can say it's 1 over analysis arctan urine analysis plus Carl. So I really just need to locate these and make sure my DU gets accounted for. Let's go take a look. I'm going to put an E to the X up there. Otherwise, it's not going to work. So let's say A is 3. Check. Let's say U is something squared. What squared equals e to the 2x? How about e to the x? E to the x times e to the x is e to the 2x. I've got u taken care of. Du, in this case, du is e to the x dx. So I don't even need any kind of a correction for that one. So I'm ready to go. Once I recognize that I've got my a, I've got my u, and my du is the whole rest of the integral, I'm ready to go. My answer is 1 over analysis arc tangent urine analysis. And it'll stick with you. We're done. What I'd like you to do is, if the sub could pass out the worksheets, you'll notice there's a worksheet that says it's 1 through 10. These will be due. If you can get it to me by the end of the hour, maybe I'd give you a little extra credit. I am posting the worked out solutions to these on Schoology, so some of you might need some help on this. Again, these are advanced topics, not our regular Calc 1 topics, so if you need some assistance, you can go look there. If the sub could pause this video and pass it out, then restart the video once everybody has one. I'm going to work through number 4 for you. So let's go take a look at number 4. By the way, I didn't try to trick you on any of these and have them not be arcsine or arctangent. I didn't throw any U subs at you or anything. These all have the inverse trig in their answers. So let's go take a look. You should have a worksheet, and we are going to go do together number 4. And you should have enough room on the sheet. So number 4 is the integral of a t. I hate when they use t's instead of x's. Oh, well, whatever. I shall monitor and adjust. It will be malleable. All right, let's go take a look. This one looks, again, first of all, look at the format. Will U sub work? Not a chance, because if I chose U, it'd be this denominator, and I get a negative 4t cubed. U sub fails. But then I notice, hey, this looks kind of arcsine-y. It's got that root, it's got that subtraction. Let's go see how that would play itself out. All right, what is being squared? Because that's our A. What is being squared? Because that's our U. Right? Be careful. Always du it. I'm not going to get exactly dt on this one. I get 2t dt. So in addition to my model, I also need a 1/2 fraction correction on this. So let's go write this out exactly as it would look. If I were to write this out, I really have, this is a half du. This t dt is 1/2 du. I would have a 1 on the top, and I have a square root of a squared minus u squared. And again, you don't really, I'm writing this all out because I'm teaching it. But once you have it in that model, then this part of it, the 1/2 is out front, is arc sine u over a. Obviously, you wouldn't put the 1 there. And again, this 1/2 isn't in our model. Tangent has a 1 over a, arctan u over a. But arcsine is just u over a. But my half came from the fraction correction. I'm kind of feeling the urge to do one more, just because. Let's go take a look at, actually number 8's like one in your book. Let's try an arctan one just for fun here. How about number 7? All right, let's go take a look at 7 together. Actually, I'm going to be done because this is reaching 25 minutes and they don't like to upload. So I'll put the key on Schoology worked out so you can use it. Use the rest of your time to work well, and you have a good one, guys. Thanks for putting up with me here.